In this video, we will define the reference angles and we will see what formulas we use to find reference angles for angles between 0 and 360 degrees. Then we will see how to find reference angles for angles greater than 360 degrees or 2 pi radians or for negative angles. In the last part, we will use reference angles to evaluate trigonometric functions and expressions that contain trigonometric functions. So let's start with the definition of a reference angle. A reference angle is a positive acute angle formed by the terminal side of an angle in standard position and the x-axis. So let's see how we can find reference angles in each of the 4 quadrants. Here we have the rectangular coordinate system and we will draw an angle in standard position whose terminal side lies in quadrant 1. And an example of an angle whose terminal side lies in quadrant 1 can be a 40-degree angle. So let's start by drawing the initial side, and it has to be on the positive x-axis, and the terminal side will be in quadrant 1. Now, because this angle is positive, we will use the arrow to show counterclockwise rotation, and the measure of this angle is 40 degrees. We can also name this angle using the letter theta, and we can say that theta is 40 degrees. Now, let's find the reference angle. The reference angle has to be an acute angle formed by the terminal side of the given angle and the x-axis. In quadrant 1, the reference angle is the same as the given angle theta because this is the acute angle that is formed by the terminal side of theta and the x-axis. This angle is always positive and it doesn't have any direction. Now, the notation we will use here for the reference angle will be theta ref, and in quadrant 1, theta ref is the same as theta. So then, the reference angle is also 40 degrees. Next, we will draw an angle in quadrant 2. Let the measure of this angle be 150 degrees, and we will start with the initial side on the positive x-axis. Then the terminal side will lie in quadrant 2. And this angle is also positive, and we will show counterclockwise rotation, and the measure is 150 degrees. Let's also write below that theta is 150 degrees. And now let's see how to find the reference angle. This has to be an acute angle formed by the terminal side of theta and the x-axis. So then here is the reference angle, and it is always positive, and the measure of this angle is 30 degrees. And as you see, to find the measure of this angle, we take 150 degrees and we subtract it from 180 degrees. So the measure of the reference angle in quadrant 2 is 180 degrees minus angle theta. And when theta is 150 degrees, then 180 degrees minus 150 degrees equals 30 degrees. Next, we will draw an angle in quadrant 3. Let the measure of this angle be 250 degrees. Then the terminal side will lie in quadrant 3. We will show the counterclockwise rotation, and the measure of this angle is 250 degrees. Let's also write below that angle theta is 250 degrees. And now the reference angle is the acute angle formed by the terminal side of theta and the x-axis. The measure of this angle is 70 degrees. Notice that to find this angle, we take 250 degrees and we subtract 180 degrees. So in quadrant 3, the reference angle equals angle theta minus 180 degrees. In this case, the reference angle equals 250 degrees minus 180 degrees, which makes 70 degrees. And now let's see how we can find the reference angle in quadrant 4. Let angle theta be 300 degrees. So the terminal side now is in quadrant 4. we will show the counterclockwise rotation, and the measure of this angle is 300 degrees. Then the reference angle is the acute angle formed by the terminal side and the x-axis. The measure of this angle is 60 degrees. To find this angle, we take 360 degrees and we subtract 300 degrees. So in quadrant 4, the reference angle equals 360 degrees minus angle theta. In this case, the reference angle equals 360 degrees minus 300 degrees, which makes 60 degrees. So here we have examples for each of the 4 quadrants, and notice that in all 4 examples I chose theta to be a positive angle between 0 and 360 degrees. So when theta is between 0 and 360 degrees, then in quadrant 1, the reference angle is the same as the given angle. In quadrant 2, the reference angle is 180 degrees minus theta. In quadrant 3, the reference angle is theta minus 180 degrees, and in quadrant 4, the reference angle is 360 degrees minus theta. In this diagram, we have these formulas placed in the corresponding quadrants. So if we are given an angle theta that is between 0 and 360 degrees, then in quadrant 1, the reference angle is the same as angle theta. In quadrant 2, the reference angle is 180 degrees minus theta. In quadrant 3, the reference angle is theta minus 180 degrees. And in quadrant 4, the reference angle is 360 degrees minus theta. Now let's see how we can find reference angles for angles greater than 360 degrees, which is 2 pi radians, or for negative angles. In the first example, let theta be equal to 500 degrees. Now, because it is more than 360 degrees, I will split this angle into a sum of 360 degrees and another 140 degrees. Then I will have the initial side on the positive x-axis, and first I will need to complete one full rotation and another 140 degrees. So here we have the initial side. Then we will move counterclockwise to complete one full rotation and another 140 degrees. Then the terminal side will be located in quadrant 2. So here we have an angle that measures 500 degrees, and this is the initial side and this is the terminal side. Now notice that the angle of 140 degrees has the same initial side and the same terminal side. Also, this angle is between 0 degrees and 360 degrees. Now, for both these angles, the reference angle is the acute angle formed by the terminal side and the x-axis. From this drawing, we can tell that the reference angle will measure 40 degrees. Now, let's see how we would find this reference angle if we would not have this drawing. In the first step, we will find an angle between 0 and 360 degrees that is coterminal with the given angle. And coterminal means that the angles have the same initial side and the same terminal side. To find coterminal angles, we just need to add or subtract 360 degrees as many times as we need. In our example, the angle measures 500 degrees. And because we need a coterminal angle that is between 0 and 360 degrees, then from this angle we will subtract 360 and we will get 140. So 500 minus 360 equals 140. And now this is a positive angle between 0 and 360 degrees, and it is located in quadrant 2. And now to find the reference angle for the angle of 500 degrees, we will use the angle of 140 degrees instead, because it has the same initial side and the same terminal side, and it is an angle between 0 and 360 degrees. And now in quadrant 2, we know that the reference angle is 180 degrees minus angle theta. Then the reference angle equals 180 degrees minus 140 degrees, which makes 40 degrees. So as you see, just like in the drawing to the left, we got that the reference angle measures 40 degrees. Now, if we review all these steps one more time, then if we are given an angle that is not between 0 and 360 degrees, then we need to find a coterminal angle by adding or by subtracting 360 degrees until we get an angle that is between 0 and 360 degrees. Once we get such an angle, then we use the rules discussed previously to find the reference angle. In the next example, let's find the reference angle for the angle of 17 pi over 4 radians. Now, recall that 180 degrees is the same as pi radians and 360 degrees is equal to 2 pi radians. So, in one full rotation, we have 2 pi radians. Now, let's find if the given angle is more than 2 pi radians. The denominator of this fraction is 4, and using the same denominator, we can write 2 pi as 8 pi over 4. So we will write 8 pi over 4, and this represents one full rotation. Then we can write 17 pi over 4 as the sum of 8 pi over 4 plus another 8 pi over 4 and plus 1 pi over 4. Then here we can tell that this angle will complete 2 full rotations and another pi over 4. Now, if we want to draw this angle, then here we will have the initial side. Then we will complete 1 full rotation and another full rotation and pi over 4, which is the same as 45 degrees. Then here we will have the terminal side of this angle. From this drawing, we see the reference angle, and we can tell that this reference angle measures pi over 4 radians. Now, let's see how we could find the reference angle if we would not have this drawing. In the first step, we will find an angle between 0 and 2 pi radians that is coterminal with 17 pi over 4. For this, we will take 17 pi over 4, and we will subtract 8 pi over 4 and another 8 pi over 4. Then we will get pi over 4, which is an angle between 0 and 2 pi radians. So both these angles have the same initial side and the same terminal side, and the terminal side lies in quadrant 1. Then we know that in quadrant 1, the reference angle is the same as the given angle. So if we use pi over 4 to find the reference angle, then we can say that the reference angle is also pi over 4. So we will write that the reference angle equals pi over 4. Now let's find the reference angle for the angle of negative 60 degrees. To draw this angle, we will start with the initial side. Then we will move clockwise. The terminal side of this angle will be in quadrant 4. So again, if from the initial side we move clockwise, then we generate a negative angle. But if from this initial side we would move counterclockwise, then we would have a positive angle that would measure 300 degrees. So here we have two angles that have the same initial side and the same terminal side, and this angle is a positive angle between 0 and 360 degrees. Also, from this drawing, we can tell that the reference angle is this acute angle formed by the terminal side and the x-axis. The measure of this reference angle is 60 degrees. Now, let's see what would be another way to find this reference angle. First, we need to find an angle between 0 and 360 degrees that is coterminal with the given angle. In this case, to find the angle, we will add 360 degrees. Then the result here will be 300, and again, this is an angle between 0 and 360 degrees. The terminal side of this angle is located in quadrant 4. And in quadrant 4, the reference angle is 360 degrees minus theta. Then, if we use 300 in place of theta, we will get the following. The reference angle equals 360 degrees minus 300 degrees, which makes 60 degrees. So then here we found the measure of the reference angle, and it is 60 degrees. Now let's see how we can evaluate trigonometric functions using reference angles. For this, we will review this table that has the special angles of 30, 45, and 60 degrees and the values of the trigonometric functions sine, cosine, and tangent of these angles. From this table, we can tell that sine of 30 degrees is 1/2, or cosine of 60 degrees is also 1/2, or tangent of 45 degrees is 1. Now above we have the following statement. Let theta be any angle in standard position and let theta ref be its reference angle. The values of the trigonometric functions of a given angle theta are the same as the values of the trigonometric functions of theta ref, except possibly for the sign being positive or negative. So let's say we want to evaluate cosine of 120 degrees. And let's say that we can't use a calculator and the only information we have is this table of special angles. So let's see how we can use reference angles to evaluate cosine of 120 degrees. In the first step, we will find the reference angle for 120. This angle is in quadrant 2, and in quadrant 2, the reference angle is found by subtracting 180 and the given angle. Then the reference angle has the measure of 60 degrees. Now in the next step, instead of finding cosine of 120 degrees, we will find cosine of 60 degrees. And for this, we will use this table we have to the left. Here we see that cosine of 60 degrees is 1/2. So we will write that cosine of 60 degrees equals 1/2. Now here we have to understand that because a reference angle is always an acute angle, the value of any trigonometric function will be positive. Now if we read the statement above one more time, here it says that the values of the trigonometric functions of a given angle theta are the same as the values of the trigonometric functions of the reference angle, except possibly for the sign positive or negative. This means that if cosine of the reference angle is 1/2, then cosine of 120 degrees is also 1/2, except we need to figure out if we need a plus or a minus in front. So let's write that cosine of 120 degrees is also 1/2, but let's leave some space in front because we need to know if we need to put a plus or a minus in front. The angle of 120 degrees lies in quadrant 2, and in quadrant 2, cosine is negative. Therefore, in front of 1/2, we have to put a negative. And now we have that cosine of 120 degrees equals negative 1/2. So what we have to retain here is that the value of a trigonometric function of a certain angle is the same as the value of the trigonometric function of the reference angle, except we need to know in what quadrant this angle is, and then we will know what sign we need to put in front, a plus or a minus. Now let's see another example. We will evaluate the expression sine of 45 degrees plus cosine of 50 degrees plus cosine of 130 degrees without the use of a calculator. We see that the first two angles are acute angles, but the last one is an obtuse angle that lies in quadrant 2. We will bring down the first two terms, so we will have sine of 45 degrees plus cosine of 50 degrees. And now let's find the reference angle for 130 degrees. So here we have the angle, and the reference angle will be this acute angle formed by the terminal side and the x-axis. From the drawing, we see that the reference angle measures 50 degrees. Now, we also know that if we take cosine of 50 degrees, because 50 degrees is an acute angle, the value will be positive. But if we take cosine of 130 degrees, then the value will be negative because in quadrant 2, cosine is negative. For a better understanding, if we want to use the calculator, then we will see that cosine of 50 degrees will be approximately 0.64, while cosine of 130 degrees will be approximately negative 0.64. So what you need to understand here that the values of these two functions are the same, except this one is always positive, but this one can be positive or negative depending on the quadrant. Now, if these two functions have opposite signs, then I can write the following. Cosine of 130 degrees is equal to negative cosine of 50 degrees. So to make these two equal, I need to put a minus in front of one of them. This way, I can say that the left side is approximately negative 0.64 and the right side is also negative 0.64. Now, in the expression above, I want to replace cosine of 130 degrees with negative cosine of 50 degrees. So I will write minus cosine of 50 degrees. And now the last two terms will cancel, and I will have sine of 45 degrees. And in the table from the left, we have that sine of 45 degrees is square root of 2 over 2. So then the value of this expression is square root of 2 over 2.